Here we have the floor plan for our project in 2D. We will first define our walls for the structure. In the Room Manager, we select Database to set up the calculation. Under Workspace, select Room Areas, the external walls. The wall construction system appears. You are able to select your walls from the database, or you may create your own specifications. We will select a block wall, stucco finish on both sides, along with its insulation and the insulation value. The U factor of the wall is determined by the section. Layer 1 is interior stucco, Layer 2 is concrete block, and Layer 3 is insulation board, including vapor barrier and stucco for Layer 4. Next, we will analyze the vapor diffusion. The graph will show temperature, saturated pressure, and partial pressure. The blue highlight on the exterior or left side of the wall indicates the moisture content of the complete wall assembly. This is especially important in areas where the winter temperature conditions have high humidity and low temperatures. Here, the red indicates the inside of the wall. Layer 1 is 20 degrees Celsius. And the blue is the exterior, Layer 4, which is -10 degrees Celsius. Layer 2, the block, is 16 to 18 degrees Celsius, and the Layer 3, our insulation material and vapor barrier, is 16 degrees to -9 degrees. This wall is now defined for our calculation. In the C.A.T.S commander, we select the Command Draw Wall. We will select the wall assembly we have just created. We will trace the length of the exterior walls. You must trace the exterior wall boundary of the exterior wall. As you can see, the snap points are selected, even with complex geometry. The last straight section will automatically be calculated. Do not return to your start point with your snap point, but stop at the last straight line prior to your beginning point. You will now right mouse click. When the context menu appears, select Close. In Room Geometry, we will select Walls. We will now choose our interior wall construction. The predefined wall construction appears in a window, or you may change its characteristics. We now trace our interior walls. At the starting point, it is necessary to click both sides of the wall, and in this case, the exterior wall starting point. The same procedure is required when you trace all interior walls. In the C.A.T.S commander, we select Openings. Our window opening database appears. We select our window type. You are able to select a default window height or edit the database height. Similarly, we will snap the horizontal borders of the window. The same procedure applies to the exterior doors. In this presentation, we will not calculate the interior doors. However, it is done in the same way as the exterior doors. In the C.A.T.S Commander, we will select room numbers. We can define story, room number, and room name. You can click on the room description on the architectural drawing and it will copy to the window. Now a block appears with a text box for the room and includes set points for heat load and cooling load calculation. We will select floor and ceiling assemblies in the C.A.T.S Commander. We can select from the database or edit the database if needed. Highlight the entire drawing interior. The color changes in the text block to yellow, indicating the floor and ceilings have been assigned. We will select the command Edit Room Number. We are adding all of our rooms to the cooling load calculation. We will now assign load profiles to our training center. "30 people, number of lights and appliances." We can select the method of regulation such as a system on and off. Select infiltration rate. Machinery is not calculated or the components such as ceiling cooling without airflow. We will assign the wall components to each room. We will highlight the entire drawing selecting all rooms. Now you have assigned the wall components. By clicking on one of the room numbers, you're able to see that the entire floor area changes color. This signifies that the room is ready to be calculated and has been assigned properly. Repeat the procedure for the other rooms. We are now ready to complete the cooling load calculation. In the C.A.T.S Commander, we will select Calculate Cooling Load. The data shown here is all of the data exported to the spreadsheet required for the calculation of the heating or cooling load. We are selecting the training center to calculate its cooling load in this example. We select the profiles indicating there are 30 people in the room. The activity level is light as selected in the profile. The lighting is shown here. The regulation profile indicates the room is occupied from 7 a.m. to 5 p.m. It is off the remaining period. We will address this later in the calculation. We start the calculation process by selecting the Calculation tab to the right. Select Building. The window appears, allowing the parameters to be established. In our example, we will select January, July, August, and September. The building is located in Orlando, as you can see. The system parameters are displayed to the right side of the window. Our first step is to select System Off at the top of the parameter list. Select OK. Now select the Calculation tab and the graph appears simulating our training center. We see the room set point here, 24 degrees Celsius. We now see the actual room temperatures over the period of 24 hours. You can see the temperature rising during the occupied period as we have no cooling. Here we see the cooling load. You will see that the load demand exceeded 5,000 watts at its peak. We will select the system actual capacity, which is 0 as the system is turned off. We look at the comfort level of the room. The light green band indicates the comfort zone. The purple columns indicate the predicted percentage of dissatisfied people due to the room conditions. The red line indicates the actual room air temperature. The blue line indicates the actual operative temperature. We will now select Building again. We will now deselect System Off. Select OK. The room is recalculating. We again look at the cooling load, similar to before during the occupied period. The unoccupied period temperature is cooler than our previous example with the unit turned off. We look at the cooling capacity, 6,000 watts, which now equals the cooling load. We now see the actual room temperature during the occupied period is well within the comfort zone. With a number of dissatisfied people less than 10%, this is acceptable and within accepted standards. By clicking the left drop-down menu, we will select Body Heat. The green column is Latent Heat Load, and the blue is Sensible Heat Load. In the drop-down menu, we select Outside Air. The blue indicates dry bulb temperature, and the purple is maximum outside latent load and the time indicated. In the drop-down menu, we select Solar Radiation. The purple curve indicates the maximum solar radiation of a surface to the sun. The green indicates horizontal surfaces. The light blue is north exposure, pink is east, south is turquoise, and orange is west. We are now going to limit the cooling capacity to 5,000 watts. We enter 5,000 in the capacity column and recalculate. We first see the curve at 5,000 watts capacity. The cooling load, however, is up to 6,000 watts. The room air temperature increases over set point to 26 degrees Celsius during the occupied period. The comfort zone indicates that we are in the allowable limits of the comfort zone at 16% less capacity. The percentage of dissatisfied people rises only slightly. By clicking the Room tab, we will select a new profile for the room and recalculate the air supply. Select Regulation and the tab to the right. When the window appears, select Supply Air. Select OK. We now see the new profiles. Select Calculation. The green columns indicate the required supply to meet the set point. The blue line indicates the supply air temperature, and the pink indicates the actual room air temperature, and the orange line indicates set point. During the occupied period, the room temperature equals the set point. The air supply is at 2,900 cubic meters per hour. We will now change the supply air temperature from 19 degrees to 20 degrees. This will now require 3,600 cubic meters per hour at a requirement of over 20%. With the flexibility and ease of input with the C.A.T.S cooling load calculation, the designer can easily change system parameters and view the impact of his changes. Checking the comfort zone, we are within our boundaries. Here we are checking body heat gain. We will now create zones and select our rooms. On the Property page, select Zones at the bottom. Select Create Zones in the Contact menu. Select all of the rooms that are to be in the zone. Select OK. Select Cooling Load, and then select Go to Zone. We will now see the cooling load of the complete zone.